Hey everyone, and welcome to this explainer. So today we're actually stepping into a virtual builder's workshop. When you really think about it, coding is incredibly similar to carpentry or construction. You start with raw materials, your wood, your bricks, your nails, and you use specific tools to assemble those pieces into something amazing, like a working program. Today, we're going to unpack your brand new Python toolkit. We'll look at the exact materials you'll be working with, and even more importantly, how to use your coding tools to build something totally from scratch.
Here's the rundown for today's explainer. Python's basic data types, numbers, integers and floats, strings, operators, and finally, advanced mathematical operators.
Section 1, Python's basic data types. Okay, let's dive right into this.
Before you even think about swinging a hammer, you really need to know your materials, right? In Python, these materials are called data types. Every single piece of information your program handles has a very specific type, and Python really needs to know what that type is to work with it correctly. To help us identify our materials, we've got the Ultimate Inspector tool. The quote on screen highlights this perfectly. It's the type function. By simply passing a value into this function, say writing type 12, Python will literally print out the class or category of that data block. It helps the computer, and it totally helps us, understand exactly what kind of foundational building block we're holding in our hands.
Moving on to Section 2, numbers, specifically integers and floats.
Let's start inspecting our very first raw material, numbers. Now, you absolutely don't need to be a math genius to code, but you do need to understand how Python categorizes numbers. In our coding workshop, numbers basically come in two very distinct flavors. The first flavor is the integer, or just int for short. Think of integers as your solid, unbroken blocks. They're whole numbers. They can be positive, they can be negative, or they can be zero, like 4, -762, or 0. The defining characteristic here is that they absolutely do not have a decimal point.
So let's test this out real quick. Is -100,000, written out with a comma, an integer data type in Python? Well, actually, no. Python is super strict about this. Numbers are only considered integers if they're written without any commas or other non-numeric characters. To the computer, that comma completely breaks the rule. You have to strip all that punctuation away and write it literally as -1000000.
Now, what's really fascinating is contrasting that with our second flavor of numbers, floating point numbers, or floats. The term float basically comes from the fact that the decimal point can float around to any position. The very second a decimal point appears, Python treats it as a float, even if the decimal part is mathematically just 0. So a plain 0 is an integer, but 0.0, that's a float. In Python, even -0.0 is a perfectly valid floating point number, uniquely distinct in its data type from a standard 0.
All right, Section 3, strings, magic with text.
We've got our math blocks sorted, so let's pivot over to language. Our next raw material handles words, sentences, symbols, the whole shebang. In Python, we call this material strings. And I absolutely love this analogy from the source text. Think of a string as a collection of characters, kind of like beads on a necklace. Every letter, every number, every symbol, or even a blank space is a single bead. But to keep those beads from just spilling everywhere, you need clasps on both ends. And in Python, those clasps are your quotation marks. Here is how you properly string those beads together. For valid strings, you can use single quotes or double quotes. Either works as your clasps. You can even put numbers inside them, and Python treats it as text, not math. But you have to watch out for the critical danger of mixing your clasps. If you open with a single quote, you cannot close with a double quote. And if your text has an apostrophe in it, like let's go, enclosing it in single quotes is going to confuse Python. It thinks the string ended early, which completely breaks the clasp.
Time for another quick test. Are these two sets of quotes actually considered strings in Python? One has absolutely nothing inside, and the other just has a single space. Believe it or not, yes, both are strings. The first is what we call an empty string, basically a necklace with no beads, just the clasps. The second one holds exactly one invisible space character bead. Python treats both of them as perfectly valid strings. Because you're going to use strings all the time, Python gives us special built-in tools just for them. You can use a standard plus sign to concatenate, which is just a fancy way of saying joining two separate strings into one longer necklace. You can use triple quotes to create massive multi-line strings. Though be warned, if you forget to close those 3 quotes, you will trigger a nasty syntax error every single time.
You also have tools like replace to swap out specific text and find to pinpoint the exact position where a character is hiding. Next up, Section 4, Operators, your coding tools. So we have our raw materials, our ints, floats, and strings. The wood and nails are ready to go. Now we need the hammer and saw to actually connect them. In Python, these tools are called operators, and this brilliantly illustrates the broad family tree of these coding tools. Operators are really just special symbols that carry out specific tasks on your values. The values themselves, by the way, are called operands. Operators fall into different categories, like assignment operators to store data, comparison operators to check if things are equal, and logical operators for decision-making. Today, though, we're zeroing right in on the arithmetic operators.
But first, a major warning about a super common human-to-machine translation error. In high school math, if you write x equals 2 parentheses 7 plus 5, literally everyone knows you mean multiply the 2 by the result of the parentheses. But Python is not a mind reader. If you type this exact line, it will throw an error. You have to explicitly use your coding tools. You've got to include the star symbol for multiplication, writing it out as 2 star parentheses 7 plus 5.
Here are your basic arithmetic operators: addition, subtraction, multiplication, and division. These act pretty much exactly like you'd expect, but there is a really interesting quirk when you start combining data types. If you add, subtract, or multiply two integers, your result is going to be an integer. 5 plus 3 equals 8. Simple enough. But division is unique. Standard division using the single slash always yields a float. 8 divided by 4 doesn't give you the integer 2, it gives you the floating point number 2.0. Bringing us to Section 5, Advanced Mathematical Operators. So standard division leaves us with floats. But what if we really just don't want a decimal? That's where we reach for the power tools in the Python workshop, advanced operators. We've got the double slash for floor division, the percent sign for modulus, and the double star for exponentiation. Exponentiation is easy. It simply raises a base to a power. So 2 double star 3 is 2 cubed, which is 8. The modulus operator gives you the remainder of a division. So 10 modulus 3 leaves a remainder of 1. But the crucial point here is how floor division, that double slash, works. It literally chops off the decimal, rounding straight down to the largest integer that fits. 9 divided by 4 is 2.25, but 9 floor division 4 simply gives you 2. It drops the decimal completely.
Now, what happens if you throw all these tools into one big equation? Python uses a highly predictable sequence to evaluate them, strictly moving from left to right based on precedence. First up, parentheses. So here, 10 plus 5 becomes 15. Next, it handles multiplication. 15 times 2 is 30. Then division. 8 divided by 4 gives us our float, 2.0. And finally, subtraction. 30 minus 2.0 leaves us with the final answer of 28.0. Your tools will fire in this exact logical order every single time.
Let's do one final knowledge check to see how our materials and tools interact. What happens if you mix data types? Say you try to evaluate a float, 7.5, with an integer, 3, using floor division. Now, we know floor division chops off decimals, right? Well, it successfully figures out that 3 goes into 7.5 2 times, rounding down. But, and this is a big but, because one of the original operands was a float, the result is returned in float form. It doesn't give you the integer 2, it returns 2.0. The data type of the materials dictates the data type of your final product.
And just like that, you've got a handle on the essential contents of your Python Toolkit. You know how strings act like beads on a necklace. You understand exactly how integers and floats behave. And you know how to wield operators to manipulate all of it. You've mastered your raw materials, and you know exactly how to swing the hammer. So the only question left is, armed with all this knowledge, what are you going to build next? Thank you so much for joining me in the workshop today. Get out there, open up your editor, and start experimenting. Happy coding!